So this whole chapter, they're going to ask us a lot of questions about finding a limit, right? We talked about them yesterday, the graphing ones. That's the number one. Graphically is, what is y doing? What y value are we getting closer to as x is getting closer to a number, right? Which y value are we approaching as x is getting closer to that number, right? We did it graphically. The other two ways are using a table. Using a table takes a while, so it's rarely seen. I've never seen a table question on a test, but I always show it to students just to show them this is what I mean by finding a table. So that's why I say rarely used. It's rarely used. You don't have to worry. You might have one or two like problems on your homework about it, but in the big scheme of things, using a table to find a limit is not something you need to worry about. The big one though is number 3. The one you're going to see more often than not is number 3. That's the most common. That's doing it either analytically or algebraically. Okay, the way we're used to doing it. Okay, so let's go over table first. Table, like I said, you're not going to see this. You're rarely used, but still important. So let's say you have this equation. F of x is x squared minus 4 over x minus 2, right? That's the equation. And it says everywhere that x can't be 2. Why is this notation there? Does anyone know why that notation is there? Why did they put that there?
Because it's just going to be 0. That's the solution.
Because what? Yeah, what happens when I plug in 2 to this guy, right? I get 0 over 0. 0 over 0 is what we call indeterminate form. We don't know what it is, right? You guys have been taught from like forever that if I have a fraction, let's say I have 0 over some number, any number, what is the answer going to be?
0.
0, right? It's like saying I have 12 slices of pizza, I get nothing, right? No pizza, all right? But let's flip it around. What is 12 divided by 0? Undefined. It's not a number, right? I can't have 12 pieces and there's no pizza. How can I have 12 pieces of pizza and there's no pizza, right? I can't do that. That's just, it's undefined. So we call that undefined, right? It's not a number, right? If you're not sure, ask your calculator. Try 12 divided by 0. It'll either say error or it'll say undefined, okay? So there's a difference, right? This is 0. 0 slices of the 12 slices. I get 0 out of the 12. That's a real thing, right? How about 12 slices when there's no pizza? How can I have 12 slices of something that doesn't exist, right? That's why it's undefined. The last one is this, which you haven't really seen up until this class. 0 over 0. Here's the question. Is it 0? I have 0 on top, but I also have 0 on bottom. So is it 0 or undefined? It's indeterminate, so that's why we could call this an indeterminate form. Because we don't know what it is. Is it 0? Is it undefined? I don't know. Okay, so we're going to see that. We're going to see that this chapter. Okay, all right. So again, that's what happens if I plug in 2, right? 2 squared is 4, minus 4 is 0. 2 minus 2 is 0. Right? I know what to do if it's undefined. It's just an asymptote, right? Or a hole, right? It means it doesn't exist there. I know what to do if it's 0. 0's on a graph. I could just, 0's a number, right? Indeterminate, I don't know how to deal with that. So that's their way of saying f of x will work for everything except 0. 0 won't work, okay? Okay, so y is not included because if I plug in 2, I get an indeterminate form, right? If I plug in 2, y is excluded because plugging in 2 would create an indeterminate form. When I don't even know what the number is. Is it undefined? Is it 0? Mm-hmm. Right? Not B, by plugging in 2, okay? Okay, so now let's look at the table. So what I did was,
Wait, what is this?
by plugging in 2 would create an indeterminate form. It would create one of these guys right here, right? I don't know what that is. Okay? It's not 0. It's not undefined. Okay? Okay, so here we go. So what I did was I plugged in a bunch of numbers. I plugged in 1.5, 1.75, 1.9, 1.99, 2, 2.001, 2. I plugged in all of these numbers into the calculator, into this guy right here, right? It says undefined, but really it's indeterminate, right? We talked about that. I just put undefined because I think that's what the calculator put. I think a Desmos will call that undefined, even though it's really not. Okay, so if I plug in 1.5, so 1.5 squared minus 4, right? And then 1.5 minus 2, if I do that, I get 3.5. Okay? So use this to determine what is the limit as x approaches 2 for f of x. So complete the table, it's already done for us, to determine what happens as x gets close to 2. So we just follow. As x gets close to 2, what is y doing? What is y doing as x is getting closer and closer to 2? It's getting closer and closer to 4, right? It's not getting there. Will it ever get to 4? No, right? It will never get to 4, but it's getting really, really close to it, right? What is it doing from the other side? It's doing the same thing, right? Will it ever get to 4? No. But it's getting really, really close to 4. So what do we call that? We say the limit as x approaches 2 for this guy here is 4. What is it approaching, right? That's the difference between a limit and an answer, right? If I said this, what would that be? Yeah, we couldn't tell, right? We couldn't tell. This, because that's the solution, right? There is no dot there. Might be a hole, might be an asymptote. We don't know what's going on there, right? Indeterminate, they would accept undefined too, just like the calculator, even though it's not really undefined, right? That's the difference between a limit and everything else that you've done so far, right? Okay? It's not hard, but they don't ask you to do that a lot just because because it's kind of easy. It's just not, but they always want you to know how to solve it using a table. Okay? So you just do the same thing. Start from the left side. We call this the negative side, right? What's happening as I'm getting closer and closer to 2? I'm getting close. Y is getting closer and closer to 4, right? Am I approaching the same number from the other side? Yeah. So when that's the case, you found your limit. If this was approaching 4 and that was like a 5 or a 6 or a 7, all these numbers were different, right? Then it would be does not exist, right? Because they're approaching 2 different numbers. Okay? Not too bad. So the big one, the one we're going to spend most of our time with, is called analytically. Sometimes it's analytically, sometimes it's called algebraically. It's the same thing. Okay. So anytime we have a limit problem, the first thing we're going to do is plug in the limiting value. So whatever the limit, what am I approaching? Plug that in. If you get a number, any type of number, positive, negative, could be a fraction, could be a decimal, it doesn't matter what it is. You're done, move on. That's what we hope for. We always hope that when we plug in, we get an answer and we can move on. There's going to be some times, there's going to be 2 times when we don't get that. Sometimes when we plug in the value, we're going to get 0 over 0. 0 over 0 means you're not done yet. Keep going. Keep going. If I get a non-zero over 0, we're done. Does not exist. That means the limit doesn't exist. Okay? So if I plug in my number and I get this, keep going. We still got work left to be done. If I get this, 12 over 0 or anything over 0, DNE, we're done. Does not exist. This is just 0, right? If I get something over 0, that's just 0. That's just the answer for 0. Okay? Let's say I plug in my number and I get 0 over 0. That means keep going. What other options do I have? Well, I can factor. Greatest common factor. What I mean by factoring, you guys have done it a million times. Factoring, once you start to see it, GCFs, you know, the thing with the X and stuff like that, that's called factoring, okay? You guys have done that before. Once we do a problem with that, you're like, I remember that, okay? Common denominator, when do we use common denominators? When we're doing what? When do you hear the word common denominator? We need a common denominator. A fraction, yeah. So when we have two fractions that need to be combined, either added or subtracted, that's when we do common denominator stuff. Conjugate, you might not have heard of. You might have heard of conjugate. I'll explain that one. That one we don't use a lot, but it is an option. It is one of our tools that we can use. Okay? All right, so we're going to go through this. Even though there's not a lot of practice problems on here, we're going to go through it slow because I want you guys to kind of get the hang of it. Okay? Because this is one of the more important things that we do, especially this chapter. Okay? Oh, a couple other things. Oh, we talked about that though, right? When limits don't exist, right? When do we get a limit that doesn't exist? When we get a non-zero over 0. Okay? Common types of behavior associated with limits that don't exist. Approaching different numbers, right? So if it's a situation where on the left side it's approaching one number, on the right side it's approaching another y value, that doesn't exist. Increases or decreases without bounds, and then oscillates. What's oscillate mean? Have you guys heard that word before, oscillate? Sometimes you hear it with a fan, an oscillating fan. What does it mean if a fan oscillates? Goes back and forth. Oscillate means goes back and forth, right? So one thing that oscillates, one graph or one function that oscillates, what does this? Sine and cosine, right? Sine and cosine oscillate. That's what it means. That's what it means by oscillating. You don't see it a lot, but it goes back and forth, okay? On the back page, it probably doesn't make much sense to you right now, but once we do this, it will make sense to you, and it's a graphic organizer to say, what can I try? How can I get a limit? What have I tried? What can I try? Doesn't make much sense to you right now, but it will once we start doing problems. So I always throw it on there just in case. Okay? All right, so let's look at the first problem. Let's look at 1a. Okay. So how do we know it's a limit problem? Because it's got a limit, right? And the limit is x approaching 2. There's no table, there's no graph. So that means it's algebraically or analytically, right? So what do we know? What's the first step we should always do when we're trying to find a limit this way? Plug in the value. What am I plugging in? 2. So let's plug in 2. Where do I plug in 2? Everywhere there's an x. You guys got it. So 2 squared over 3 times 2 plus 4. So 2 squared is 4. 3 times 2 is 6, plus 4 is 10, right? So we get 4 out of 10, which can reduce to 2/5, right? So this is what I got right here. So let's go to back to my chart. Did I get 0 over 0 when I plugged it in? No. Did I get any non-zero over 0? Nope. I didn't get any zeros, right? That's your answer. That's what we hope for every time. Every time we hope for that. Now, is that the case? No. It's not going to. The next problem is going to be a different situation. But every time we hope when we plug in this number here, we get something that doesn't have a 0 on. Well, non-zero over 0, that's okay, because then does not exist. But this is the guy that's going to come up a lot, 0 over 0. That means we got to keep on working. Okay? All right, so let's try B. This one's called a piecewise function because it's got multiple pieces, right? So we have 3 minus 2x squared, right? When do we use that one? When we're plugging in what numbers? Because it's got two pieces, right? So we got a yellow and we got a green, right? We got a yellow and we got a green. When do we plug in numbers into the yellow and when do we plug in numbers into the green?
Depending on if it's 2 or less or 2 or more.
There you go, right? If the number is bigger than 2, we're going to plug it into the yellow. Don't worry about the green. If the number is 2 or smaller than 2, we're going to plug it into the green. Don't worry about the yellow. Okay? It's called a piecewise because it's got 2 pieces to it, right? It's got 2 pieces to it. Those are the ones that have, like, from yesterday when we were talking about, what do those graphs look like? Those graphs look like, remember all these like jumps and stuff like that? That's what causes those, is the piecewise function. So those guys are all a bunch of piecewise functions. It's got a different piece, right? It's got one piece, then another piece, then another piece. So that one probably has like 4 pieces. Okay. This one only has 2. Oops. Okay. Okay, so I got the limit as x approaches 2. So what am I going to do first? What's my first attempt to solve for the limit? So I need to figure out the limit as x approaches 2 for f of x, right? What's my first method I always want to try? Plug it in, right? What am I going to plug in and to which one?
You plug the 2 into green.
Plug the 2 into green. Great. Green, why green? You guys are right. Tell me why.
Because it's equal.
Because it's equal, right?
Equal or smaller than 2.
There you go. So let's plug in 2 to green. I get 4 minus 9, right? Which is negative 5. Did I get 0 over 0? You're done. You're done. Okay? We didn't even use the yellow. Didn't even worry about the yellow. Okay? All right. So let's go to problem C on the next page. So this one is the limit as x approaches negative 1. What's the step we should always try first when we're doing a limit problem? Plug it in, right? Plug it in. So plug it in. Let's plug in negative 1 everywhere there's an x. And let's see what we get. So we get negative 1 squared is 1, right? So 2 times 1 is 2. And then those 2 are negative minus a negative, right? So it's that. So we get 2 plus 1 minus 3 on top, and then 0 on bottom, right? So we get 0 over 0, right? So 0 over 0 means not the end of the world, it just means keep going. It means we're not done. Okay? All right, so what are our other steps? We have factor, common denominator, multiply by conjugate. This one, I'm going to use factoring. Why am I going to use factoring? Because the top is a trinomial, right? I think I can factor those guys. Okay? It's actually a quadratic, right? So what I'm going to do is I'm going to try to factor the top and factor the bottom and see what happens. Okay, so the top is a trinomial, right? A trinomial. 2x squared minus x minus 3. Okay? So it's got 3 pieces to it. It's got an a, it's got a b, and it's got a c. Those are the numbers in front of each one. So what is a? 2. What is b? Negative 1, and c is negative 3, right? When it's a trinomial, you can do that. If it wasn't a trinomial, we would use other steps to factor, But since it's a trinomial, it's going to have an A, it's got to have a B, it's got to have a C. And then we use those, right, to do that guy. So we multiply A times C, right? A times C. So when I multiply A times C, what do I get? -6. B goes at the bottom. And I try to come up with the two numbers that multiply to be -6 and add up to be -1. What are those two numbers? 3 and 2. All right. One of them has to be negative, though. Which one's going to be negative? 3. From here, different teachers do it different ways. Depends on who was your Math 2 and Math 3 teacher. I teach it one way. Mr. Yates, I think, teaches a different way. I think Mr. Siegel teaches a different way. I'm not sure about Mr. Feistel, but it's just different ways. So I'll show you the easiest way. Since this is not a Math 1 or Math 2 class, I'll show you guys the easiest way to do it. So what you do is you put them together now. So I have a -3, right? So it's going to be x minus 3. And I have a +2, right? So x plus 2. This is not the only way to do it, by the way. This is not the only way. So if this looks weird, I know. It's probably because your teacher taught you a different way, but I'm just teaching you the easiest way. Their last step is to divide by A. Divide by A. What was A again?
2.
So you're going to divide this guy by A, and you're going to, wait, let me use a different color so it's not confusing. This guy by A, and this guy by A. So does 2 go into 3 evenly? No. So we call this bottoms up because if it doesn't divide, it goes over here. So it's 2x minus 3. So the 2 went over here. It doesn't go in evenly, right? So the 2 go here, 2x minus 3. This one will divide evenly, right? What is 2 divided by 2? +1, right? So the yellow factored to make this. Both yellows are exactly the same thing. One is just factored and one isn't. Right? It's like writing, instead of writing 18, I write 6 times 3. Aren't those both 18? It's the same thing. This one is this times this, so it's kind of like 6 times 3. That one up there is already multiplied. Okay? It's just broken down, in other words. Okay? So I'm going to rewrite the problem now. I'm going to rewrite the problem. The limit as x approaches -1. The yellow, I'm not going to write 2x squared minus x minus 3. I'm going to write the factored version. 2x minus 3. X plus 1. The green, how do I factor the green? The green is a binomial, right? So we can't do A, B, and C because it doesn't have an A, B, and C. What you do is GCF. What is the greatest factor that goes into these two guys? It's kind of a trick question. 1, right? It's 1. So if the GCF is 1, that means you can't factor it anymore. It's already factored. So this guy I'm going to leave as x plus 1. What do you notice now when I rewrite it?
You can cancel it out.
I can cancel them out, right? I can cancel out this guy and this guy. They divide. Anytime you're dividing something by itself, the answer is 1, right? So now, once I factored, let me go back to plugging it in again. So plug in the value. What do we get when we plug in the value now?
0.
So we get, let's see, so we get 2 times -1 minus 3, right? And then these guys are just 1. So this guy is times 1 and then 1, right? That's just a 1 and a 1. So those guys aren't going to do anything. So what do we get? -2 minus 3, we get -5, right? That's the limit. Once we stop getting 0 over 0, we're done. We're done. Okay. So when do we use factoring? When we can. When we can. Usually there's always a fraction when we factor, and we want to try to cancel things out. Okay. All right. All right, so letter D. What's the first step we always do?
Plug in.
Do it right now. Plug it in. What do you get?
0 over 0.
We get 0 over 0. Pretty much the only thing we don't want to see. Anything else, we'd be done with a problem. Literally anything else, we'd be done with a problem. But you're going to get a lot of 0 over 0s. Zero over 0 means keep working. Work's not done yet. This one kind of looks like the one before, right? It's got a top and it's got a bottom. It's got some squares on the bottom. So I'm going to use factoring. I'm going to see factoring works. Okay? So again, I have a top and I have a bottom, numerator and denominator. So 2x. Let me rewrite the problem. 2x is a monomial. Can I break down 2? How do I, like when I say break down, I mean factor tree, right? Factor tree. What's the only way to make 2? 2 by 1, right? That's the only way to make 2, right? So in other words, it's already factored. Okay? So it's just 2 times x. The green is a binomial. So does the green have a GCF? Is there something that I can divide the first term and the second term by? Do they share anything in common? X, right? So that's going to be my GCF. I'm going to divide this by x and divide that by x. So x is going to be my GCF. That goes in front. When I divide by x, what's left on the first one? I took away a power, right? So now it's just x to the first power. I took away the power. It's just a 4, right? How do you know you did it right? Because if I were to do distributive property, I'd get back to where I started, right? Factored. Now we got a new yellow and a new green. Does anything cancel out?
The x's.
Good, the x. Do these x's cancel out?
No.
No, right? When I do something like that, it should just feel wrong. It should just not feel good because it's wrong. Why can't I cancel out the x's? This guy's an x, this guy's an x. Why can't I cancel those out? Say it. Because this is an x. It's whatever x is plus 4. It's a completely different number, right? So I can't do that, but this one I can. Plug in. What do I get? 1/2, right? You get 2 over 4, which is 1/2. I'm okay with that. The only thing I can't get, or not can't get, I don't want to say that. The only thing that makes me not finish with the problem is get 0 over 0. If I get 0 over 0, got to keep going. Anything else, you're done. Okay? You know what? I don't want to go on to E yet because E is a different type of problem. So I think you have room on the last page maybe. I want to give you another problem like that. Or if you have room next to this, somewhere you have extra room. Yeah, we're gonna kind of stop right now. We'll do E and F later. I'm not skipping E and F. I'm just kind of taking a break because I want to get you guys, because E and F are different types of problems. Same but different. Yeah, same but different. So I want to give you guys another problem like that just to practice. Okay, so here, try this one. Okay. So we got an E and an F, right? So we'll call this one G. Okay, so try this one. Let's see. The limit as x approaches 4, x squared minus 5x plus 4, x squared minus 16, and then h. Let me give you one more. What's a good one? The limit as x approaches 2, 2x squared minus 3x plus 1, and then 2x to the third, oops, no, minus 25. Do you guys want to try them on your own? Or you want me to do them with you?
Let's try it first.
Try it first? Okay. Go for it. We're going to go over them, but I just want to see if you guys want to bite at the apple first.
Take off lights, we can not do. Maybe we have 2x. Maybe over here.
Okay. Those are the answers, so you can check to see if you get them right. Let's see. First problem first. If you're still working, it's okay, but let me kind of explain what I did here. So the first problem, x squared minus 5x plus 4 over x squared minus 16. So I plugged in 4 to begin with, right? And I figured out that I got 0 over 0. That means I still have work left to be done. I'm not done yet. Okay, keep going. So for the top, for the numerator, the yellow, it had 3 parts. It was a trinomial. So I factored it like a trinomial. A, B, and C. A is 1, B is negative 5, C is 4. So I did my x, got negative 1 and negative 4. That means it's x minus 1 and x minus 4. And then remember, divide it by a, whatever a is, divided by a. That kept it as x minus 1 and x minus 4. And that went up here. Okay? The bottom is one of those little tricks. It's a binomial, but it's really a trinomial. Okay? The reason is the middle term, the b term, went away. They're at 0. So you can do it this way. It would just be b is 0. So you could do a is 1, b is 0, c is negative 16. You could do it that way, but it's also a special term you've definitely heard in Math 2 and Math 3. Might not remember it, but you heard it. It's called difference of squares. Difference of squares. It means when we can take the square root of both of them, it's a binomial, it's a special relationship. So what it means is, what would the square root be? Well, the square root of x is x squared is x and x, right? And then the square root of 16 is 4 and 4. Difference meaning one positive and one negative. Okay? So other ones are like x squared minus 4, x squared minus 9, x squared minus 25, 4x squared minus 25. You notice how all of these, 1, 1, 1, right? There's really a 1 there. All of these numbers are perfect squares, right? all of these numbers are perfect squares. They all have a minus in the middle, difference of squares. Okay, anytime it's a little shortcut. So x plus 4, x minus 4. Cancel them out. Cancel out. I saw x minus 4, x minus 4. So then I just plugged in 4 minus 1, 4 plus 4, I get 3/8. Okay. And then I didn't do the next one yet. I haven't done h yet. Okay. Let's plug it in. So 2 squared minus 3 times 2 plus 2, and then 2 cubed minus 25. So let's see, 2 squared is 4 times 2 is 8. So I get 8 minus 6 plus 2. The bottom I get 8, 16, 16 minus 25.
Yeah.
So let's see, on top, what do I get? 4? And on bottom, I get negative 9? Yeah, must have been wrong. The answer must have been wrong. Yeah, it's not negative 1/3. I put negative 1/3, right?
Yeah.
No, yep, you guys are right. Negative 4/9. I was wrong.
I did that question like 3 times.
No, yeah. I make mistakes, not all the time, but I do make mistakes. So please double check me. If you get something different, it could just be I make a mistake or I wrote down something wrong. Okay. So that one, we didn't need to do any of our extra fancy steps, right? We didn't need to do any of these because we got our answer when we plugged in.
Minus 25, like, that does not end in 0.
That can't be 0.
That can't be 0.
Let me change it.
I thought at first and was like,
Yeah. No, that was just my bad. All right. Good so far? Okay.
The 4 and the 1, so I gotta use the square. I got to use the square.
you know, anytime I get one of these, I'm just like, all right, can I get 0?
Okay. So we actually have about 8, 9 minutes. The next one is E, right? This one's going to take about 8 or 9 minutes. It won't take that long, but I want to go slow because I want to explain it. I don't want to go too fast. We could do this problem within that time, but I don't want to go too fast. So we'll leave this one for Monday. Okay, we'll pick up on Monday. And so I can answer some questions on, if anyone has, anyone have questions on the